Hello, everybody. So glad to see you here today. Who is having a good time so far? Yeah. Woo! Exactly. This is the spirit. So today we're going to talk about how to manage bots versus humans using Amazon CloudFront and AWS WAF. My name is Itar Arditi. I'm an edge specialist at AWS, meaning I work on a daily basis with different edge customers and seeing the different patterns out there. And lucky enough, I was edge customer for the last 10 years. So I'm very happy to share my experience today with you and later on to discuss your own challenges. Together with me on the stage is Nick.
Hi, everybody. Nick McCord, Startup Solutions Architect. So my day job is working with startups, and what I chose to do was working with services that are around going global in minutes. I just thought the concept of that was interesting. So I've helped dozens of customers of all sizes with their CDN, WAF, and DDoS problems, as well as published a few blogs and AWS solutions.
Cool. So a bit of the operations here. This is considered as a Kotok level 300. So what does it mean? We're going to deep dive. So yes, we're going to have a quick, short ramp up. But during the entire session, this is going to be quite complex concepts. So we'll try to phase it during the session. But if you have any question during it, we will have some time after this session. We're going to present a lot of code and an architecture diagram. During the entire session, both Nick and myself will have a live demo running to showcase how the different changes within CloudFront and WAF actually implemented and actually impacted our platform that we built for you. And last, Q&A. So this session is recorded, so we are not going to do a Q&A during the session, but both Nick and myself will be here for the next 15 minutes after the session, so please reach out later on, and we'll be happy to discuss. So, after the operation, we can start discuss about our topic for today. So humans, who of those know humans? I surely hope that all of us here are humans, but nowadays it's quite challenging to understand. So when all of us trying to build a product, we aim to build it for humans, to the actual legitimate users that will use our product. But since the internet began, we also saw a tremendous trend of using of good bots. Good bots are usually being used to operate the internet, to crawl, to index, to populate our websites, and eventually are good for our business. But wherever there is good, there is always bad. And this time we have bad bots. So bad bots can also try to harm your infrastructure. DDoS is the most common attack that we see out there. But bad bots can also try to replicate your IP, try to steal your content, and maybe publish it somewhere else. So we'll discuss about those two in the session. And last, we must say AI in every single session, right? So AI bots. And we see an increased trend in the last 2 years of AI bots. And this is like tricky, because this is combining all the human, bad, and good bots. Some of those AI bots, those agents, are working for humans, but some of them are just trying to showcase as they are humans. So in today's session, we're going to discuss about all those 4 topics. And as promised, a quick edge ramp up. So Amazon CloudFront Footprint is the Amazon CDN service that's mostly is being discussed when you're talking about edge. So Amazon CloudFront is built from more than 700 point of presence, that we like to call POPs, around the globe. So no matter if you want to serve a cache content, which is usually being used with CDN, but also if you want to serve your APIs closer to the actual customers, we see a lot of customers using Amazon CloudFront. And in this specific session, we're going to talk about Amazon CloudFront, Amazon CloudFront Function, and AWS Lambda at Edge, which is our compute at edge offering at AWS. We're going to discuss about AWS WAF as the protection layer on top of CloudFront. And last, we're going to talk about Amazon CloudWatch as a unified observability service to showcase the entire changes during the session.
Thank you. So how do we make all of these services work together? Well, I think a good place to start is going to be the journey, breaking down the journey of a request, which falls into 4 different stages. The first is going to be the viewer request, which before the request even hits the CloudFront cache is going to be evaluated against your AWS WAF rules, which is the protection logic you have in place broadly across your site, but more specifically for your edge cache. Next, we have our origin request. This is often commonly referred to as a cache miss. And this will happen if the content that the user has requested is not in the cache, or if the TTL and time to live has expired and needs to be refreshed. So CloudFront makes the request on your behalf to your designated origin, which then responds with an origin response. This populates the CloudFront cache, which can then be used for the viewer request and for subsequent requests from viewers that come in. This has the advantages of being more latency advantages, as well as a better cost profile. In addition to this, we have access logs. This is using CloudWatch, Kinesis, Firehose, and S3. This is going to be capturing different aspects about the request once it's been sent back to the user. This could include the total processing time of this entire flow. It could be different headers, query strings, the various fields and aspects that are being captured by CloudFront for each of them, as well as real-time logs, which is going to be making use of a Kinesis data stream and is actually going to give you those logs in seconds as opposed to the minutes that you would see with standard logs. This can be further filtered down so that you're using sampling or doing it on specific behaviors or caching policies, so that you don't have the additional cost of all of your logs being ready immediately if you don't need it. Moving more deeply into WAF, here we have a protection pack, formerly known as WebACL, if any of you have updated to look at the new UI. And this is going to be the scaffolding for our rules, our rule groups, everything that we want to do with layer 7 protection using WAF. We have various protected resources. All of these are accessible through HTTP. This could be your API endpoints, could be your Cognito user groups, but compatible with various services. And then the smallest unit within AWS WAF is going to be a rule. And so this is going to house business logic and an action. The business logic could be geo-based, IP rules. You could be looking at query strings. It's really going to be dependent on your workload, what you want to evaluate and what you want to protect about your workload. These rules can then be bundled up into a rule group, and what this does is allows you to have portability across different web ACLs or protection packs in order to make it a little bit easier in managing the overhead of rules across multiple different WAF protected resources. It's important to note that these are in priority. So if you hit a terminating rule on your rule 1 and you either block or allow that request, then rule 2 and the rule group here is not going to be evaluated. So it's important to think about what you want that flow to be. What are the, let's say, IPs or the regions that you want to block outright and you don't want to have any more advanced evaluation of, versus the ones that need to go through that entire workflow. So how this ends up looking is for your user, they should be passing seamlessly through. It works every time. They're never going to have an interruption in production impact. Threat actors are going to be constantly trying to navigate around this, which is why WAF is considered something that's not set and forget. You have to continually evaluate the rules that you're adding to your WAF. You have to look at the behaviors that are coming in and then make updates to these. Amazon does help with that. We have our managed rule groups for common use cases such as IP reputation lists or the OWASP top 10, which is in our core rule set. But this is a constant journey where you're going to be evaluating and understanding what is actually hitting your workload. So a bit of background. How many animal people do we have in the audience? A few? Okay. Fellow animal lovers. This will play out, I promise. So We built a platform out for animals, and this is largely driven by the 2024 ASPCA report, where 5.8 million dogs and cats in rescues and shelters for the year. I know we say a lot of big numbers at reInvent, so I'll put that in a little bit of context. If you were to adopt a dog every hour for 662 years, then you'd get to that number, or fill about 100 NFL stadiums. So quite a few. Additionally, the data shows the length of time in shelters and rescues is increasing, and last year alone, they euthanized over 600,000 animals. Now, why are we qualified to do this? I've been an extensive participant in fostering. We both are rescue dads, and as Itab mentioned, it would not be reInvent without a little bit of AI, so the dogs are much closer. It probably could have done a better job on us. So what we ended up doing is building out a platform for aggregating this data from the rescues and shelters. Our platform is far better because we have these relationships. It's more up to date. We have a larger pool of animals than you can find directly with the shelters and rescues. Just to switch over to the UI, here we have basic search functionality. So you can look for a particular pet type. You have maintenance level. For some reason, I continually find the high maintenance ones. You have the max age, and then for demonstration purposes, we have added a bot toggle. So this is basically to differentiate between the experience a bot is going to have on our website versus a legitimate human, as well as an admin panel where we can see logs on the adoption requests that are being submitted and logs that are being coming in from CloudFront. Swap back over here. So we got a whole bunch of adoption requests. Our platform's a huge success. Awesome. Well, wait a second. We have adopters being numerically incremented, and it appears that there's someone that's trying to take advantage of the data that we have, and they are saturating our adoption pipeline with these fake adoption requests. So as much as we might think this is the outcome of that, more than likely there is another competitor in the market that is going to be taking this data and doing it for profit as opposed to the nonprofit that we are operating as. So to summarize, we've got our pet adoption platform, tons of traffic, but only certain pets are being adopted, and we operate off 3 main KPIs, which we'll continue to come back to. The first is going to be website traffic. The second is the application review time. We have a healthy bench of adoption reviewers, and then finally is going to be the time to adopt. Well, now what do? AWS Edge to the rescue. So, QR code, you're welcome to play along with us. You all mostly look human, but for demonstration purposes, we are going to assume you're bots. So, as we're going through the different phases, you're going to see the experience that is reflective of a bot that is going to be hitting our site. So, you'll see how that plays out. On the back end, Itab and I are going to be helping each other out with AWS CDK. So we'll be doing deployments to automate this, but I'll be walking through the console, show you just how easy it is to do some of these very simple steps and into some of the code that applies to the functions. We did use a little help. We've set up a pretty sophisticated bot using Tor Cannon, and that is going to be both manufacturing traffic to our website, makes the graphs a little bit prettier. But it'll also demonstrate some of the complex nature of bots that you'll end up potentially seeing with your business. So what's our baseline architecture? Very straightforward. S3 object for storing the animal images. This is going to go to our cache. If it's a new pull, then we need to repopulate the cache. For the adoption request, this is going to go to our load balancer, backed by serverless AWS Lambda. And then we have a DynamoDB for storing those adoption requests. So if we look where it stands right now, no WAF. If you take away one thing, it's adopt a dog. I'm kidding. Turn WAF on. So we go over here, and we look at where our phase starts. We have a good bit of traffic that is coming in, and you'll notice that the number of CloudFront requests and the amount of adoption requests is all very linear. So these are unable to be distinguished between humans and bots at the moment, and we aren't doing anything to protect it. So phase 1, let's turn on WAF. What does that look like, though? is we are going to add rate limiting, which is based on a time frame that you specify. It can be down to as low as, I believe, a minute, and then up to several. This can be based on URI, IP, headers. There's a bunch of different aspects within the request that you can use to actually as the counter for the rate limiting. In addition, we're using JA3, JA4 fingerprinting. This is around SSL, TSL, TLS connections. It's a hash created by a combination of the request characteristics, and is very helpful for catching subtle tricks of a request manipulation as opposed to looking just at the geo where it's coming from, just at the IP or the user agent. And then finally, bot control. Amazon does have a managed rule group for this. It comes in two flavors of common and targeted. This is functions by monitoring, blocking, and rate limiting scrapers, scanners, crawlers, SEO. How it does this is as the requests are going through that WAF pipeline of rules that we talked about, it adds labels to it. So you can label the good bots, the SEO that you want to crawl, versus the ones that it deems to be bad. So what does this look like in our new architecture? We now have WAF coming in, and to walk you through kind of the pseudo logic that exists before we get into the console, we have request comes in, WAF is checking, hey, are you a bot? No. Otherwise, humans can progress on through. So we swap over to what this looks like in the UI. Here we have our CloudFront distribution. Oh, the burden of being tall. And you can see when it comes up that we have a WAF attached, but right now it's not blocking anything. So we're going to do a very simple change of going over to our managed rules. We have the IP reputation list. We have rate limiting here, bot control, add bot label. We have made it easy for ourselves and consolidate all of these to basically add a label to the request, which we then act on at the end. So that's the take action here. And we're going to go over and change it from count to block, save rule. And so now if we go over to our UI, I'm a normal human. I can keep searching for all of the pets that I would like. And then a bot. Oh no. Now, any thoughts on how this might reflect in our logs? Well, if it's a simple bot, they'll just give up and find a new target. However, ours are a bit craftier. So if we go into what this has done for WAF blocking, we've actually seen an increase in the amount of requests. So what we've said is that for the people that are using bots on our website, they have detected that they are being blocked, getting the 400s, and they're trying alternative methods. And what that means is they're using different request types, they are using different paths, they're saturating across a different number of IPs, and blocking. Is it blocking?
It should be.
May take a moment. We do have a prep though over here. So we see the CloudFront request go up. So it sees it's blocked, and they're trying harder. They're not going to give up easily. What this is actually doing is we have more traffic flowing, which is a greater cost to us. We have more requests that are being submitted, and it's harder for us to track. So we've actually made it a little bit more expensive for us to be able to do this. And then how does this impact our KPIs? So we have an increase in website traffic, but not in a good way. We have application review time, which has been increased because they're still trying to do it. And then the time to adoption hasn't really changed. So how can we be smarter as the implementers of the WAF logic? Well, instead of giving them the, hey, you're not allowed here, very clear stop sign, we can change from using terminating actions of block to non-terminating. There are CAPTCHAs and challenge, which some of you may be familiar with. We are specifically going to be using count. And then we're going to enhance that by adding a custom request header to those requests that are coming in and deemed to be bots. So a bot's going to come in, we'll add a header to it, and then make use of a caching policy so that if that request is deemed to be a bot, we are only going to show it a segment of our platform. This way, we can narrow down the amount of animals that are being scraped, and we have control over what is being pulled from our site. This makes it less valuable data to the bot. What does this look like in the architecture? We now have two different paths. The request comes in, and instead of outright blocking it, we are going to add the X is bot true, else do nothing. And then as it goes through and hits our caching policy, the bot is going to be redirected to our CloudFront cache. So swapping over here, off of that, we're going to look at our distribution. Right now, we have the different caching behaviors. We're going to our search path pattern and edit. We've pre-configured the bot policy here. So if we take a look at that policy, we can see the different aspects of the query strings that's a part of it. I get to copy this. Amazon WAF is going to preface the headers that are added as part of these WAF rules with the X Amazon WAF. Then we go back over here. This is going to be saved to our distribution. And then in the WAF rule, for our action, instead of blocking here, we'll move over to count and do a custom request. So now if we go back to what the experience for our bot looks like, humans still have access. Swap over to a bot. They have access, but the same access. I can keep searching, and it's going to be the same content that the bot is getting. Whereas if I'm a human, I can see hamsters, I can see bunnies, I can see all of the available animals on our platform. So now we've restricted the bot, what the bot is able to see, only to a much smaller portion. What does this mean for our KPIs? Well, overall, the deployed changes go down, the CloudFront requests go down, the WAF block track of it, there is none anymore that's blocked, and our Lambda invocations have decreased. Website traffic is now an acceptable and appropriate level for what we would expect for our platform. Our application review time, we can work with the volunteers to say, hey, this segment of animals is the ones that are in the cache and are going to have known bad adoption forms, and then the time to adoption for a vast majority of our animals has decreased.
So while those are great metrics and improvement in our application, does it actually impact what we try to solve? So if I go back to our platform and repeating what Nick just mentioned, where humans get new pets every time, but bots get the same pet, this is going to put us in a different challenge, because now bots getting the same cached response, and they're probably try to adopt the same pet over and over again. So we just moved the problem from eating all the different pets to eat only a specific pet. And both Nick and myself love all the pets. So we need to find a way and solution to somehow don't impact any of the pets doing our research. So we are going to present a couple of more approaches on how you can customize even further the traffic, the bot traffic. So we believe that different traffics deserve different response. And we're going to use a couple of concepts within CloudFront and WAF that will help us provide different response to bots, but still doesn't signal back to the bots that they're being blocked. So first, we're going to use origin modification. Origin modification is quite a new feature within CloudFront functions that allow you to override the traffic from one origin to a different origin. This is usually being used for A/B testing, where you want to split the traffic between different origins. But this can also be used if you get a signal from upstream, like the WAF upstream, and route the traffic to a different origins. Moreover, we're not just going to reroute the bot traffic to a new region. We're going to traffic to a new region that's we used an honeypot on it. So instead of just responding with a different path, we want to respond with an intelligent response that will allow us to get more insights about the attackers and maybe understand why they try to attack us. And last, we are going to use a cache busting mechanism. So Nick implemented a caching for bots, meaning bots going to get the same over and over response. But these have some caveats, because if you are going to respond for bots from caching only, you are going to lose the insights about the bots. So using CloudFront functions, we are going to implement a way to override some of the caching policies and control it according to your business logic. So in our example, we are going to cache busting for only 1% of the traffic, but you can do it for as much percent as you need. So many of those features are related to CloudFront function. So we're going to do a couple minutes 101 on CloudFront functions. So CloudFront functions are a lightweight compute running on the edge. And this is basically a simple JavaScript file that you can write, and it will run between the WAF and to your origin, meaning first the WAF happens, and only then the CloudFront functions. This allow us to read the headers that WAF is adding. So the CloudFront functions are based with, as I mentioned, a simple JavaScript. So you can use variables like string and numbers. You can define your own functions. You can use JavaScript native methods such as Spring, Lang, lowercase, and other many JavaScript native methods. You can use a more advanced methods like buffers and crypto if you want to create your own authentication within the edge. And you can also do an async operation using promise and async await. And of course, every JavaScript program should support console log. So every time that you are doing console log within CloudFront functions, it will auto ship to CloudWatch logs in USSist1, so you can later on check those logs. And you control the return. So the controlling the return is quite important. So if you return a request object, this tells CloudFront to just proxy the request later on to the origin. But if you return the event.response, that we'll see in a second, this will tell CloudFront function to terminate the request and skip the origin altogether. So if you want to do a very quick blocking on the edge after the WAF, you can do it using CloudFront function. So the event structure, we discussed a bit about the event. So we have the context, and this is like a general metadata of the distribution. So we have a request ID. This is CloudFront request ID, and this is unique per request. We have the distribution ID and the event type. So CloudFront function can be hooked to the viewer request and the viewer response. So you can write your own code according to the different viewer type. We have the viewer within the event, and this is basically the device that got connected to CloudFront. In the vast majority of the cases, it will be our mobile devices, our laptops, or the server-to-server, and this will represent the actual IP of those devices. We have the request, and the request is also modifiable, meaning you can also read the query string, the headers, and the cookies, but you can manipulate those using CloudFront functions. And as same as the request, we will also have the response when we can manipulate the status code, status description, headers, cookie, and override the body altogether. And as I mentioned before, this is quite important to understand if you want to terminate the request or just proxy it to the origin. In order to use origin modification, we are going to use a new helper that you should use the import CF from CloudFront in your own code. This helper allows us and expose 3 different methods to us. The first one is update request origin. And this allows you to override any kind of origin parameters, like the host, the entire URL, the headers, the TLS configuration. You can simply override whatever you need. So this will allow us later to route between bots and humans origin. You can also use the select request origin by ID. So you can deploy pre-made entire origin configuration. So you just stating the ID that you want to use, and it will auto-import the configuration from there. And you can also use the request origin groups, which gives you a native failover mechanism. Within the origin groups, you can define 2 different origins, and CloudFront will try to fetch the data from the first origin. If the origin will fail to respond, for example, giving HTTP 500 or 400, CloudFront will auto-retry to the second origin. And this is without your clients to be aware of it. So this is like a native failover mechanism over CloudFront. So how it all going to be connected together and how the architecture is going to be changed? So we are going to introduce a new router. We called it a traffic router. So as I mentioned, this happens after the WAF, but before our origins. And this will allow us to create this custom mechanism that our business needs. So when a request will hit the CloudFront, we will get first to WAF. Now, if WAF detects a bot, it will add the same header that Sneak added before. But instead of just going to the cache, now this new header is exposable within CloudFront function. And we are going to implement change the origin to all the bots. And for 1% of the bots, we are going to eliminate the caching. So as I mentioned before, you can do 1% or more than that. And of course, after it, we'll redirect the traffic to the cache. Let's see it in action. So in order to associate, In order to associate a function for CloudFront, you will need to choose your behavior. If you scroll down in the behaviors, you will have 4 different hooks where you can associate a function or Lambda at edge. I'm going to associate it for the viewer request. I'm going to choose a CloudFront function, and I'm going to choose a function that's pre-made. We will see the code in a second. I just deployed it very quickly. And this is all you need to do in order to have compute running on the edge. So let's check the actual code and how we implemented the different aspect that we see for CloudFront function. OK, so this is basically the handler, those 20 lines. So first, I extracted the request from the event. This is the request, and this is the headers. I have created my own isBot-detected function that's checking on the headers. Let's see. This function is just right here. And this is a simple function. It's simply to check if the WAF header that we've added before that is equal for true. Meaning, this scope of code will only run for bots. So for our users that are human users, this altogether will be skipped. For bots, we are going to randomize a number between 0 and 100. And only for 1% of the traffic, we are going to implement a cache busting. But again, we can do it 50% and do some kind of A/B test for it. The way that I have implemented the cache busting is randomize a new value and override the header that according to it, the cache policy is working. So from caching perspective, each time that we are randomizing the number, it's seeing that this is an all new request, and it's skipping the caching. And last, on row 24, I've used the method of select request origin by ID, and I've used an ID of my origin that I pre-created for the bots. I'm going to copy-paste the ID here, and let's see where it's being configured. So I'm going back to the CloudFront distribution. So I can see in the origin tabs, I now have the ID that I've used before. And this is a Lambda function URL. So you can create your own origin pre-made, having them deployed, and simply map them in CloudFront function using the ID. So let's see together how it impacted our platform. So I am currently a regular human, I hope so. And I'm searching for pets, and everything is working as expected. And the moment that I'm switching to be a bot, I started to get a bot pets. And for sure, those bot pets are not going to be impacted if any kind of bot will try to adopt them, right? You can also check it out with using your mobile phone. This is the URL from before, and hopefully you will see the same different bots that I see. So checking out the network here, you will see that the response are it from CloudFront. This means it's being cached, but only 1% of the traffic is being cached. So if I'm going to check the admin panel, I have a couple of logs already here. And as I mentioned, we are not just going to respond a different response to the bot. We want to fetch some information about those bots. So we created a simple login UI. And as you can see, we have now the information on the route the bot is trying to hit, the bot IP, the different user agents. So we see some of those are using, in this example, Phantom.js, but some of those are using an actual user agent. We have the JAF fingerprint, and this is all the metadata that I wanted to implement. Let's see how it impacts our CloudWatch. So I'm going to the honeypot routing. Let's refresh it. I'm going to do last 50 minutes. OK. So we can see here that our cache hit rate decreased a bit. And this has happened because now 1% of the bot traffic are having cache miss. But we introduce a new function. It might be a bit too small, but on the third row, we have the honeypot lambda invocation. And you can see it being hit like 4 times. So for all the traffic that we are sending from the bots, only 4 bots we actually got hit by the whole region. Let's switch. Thank you. And here we have a more simplified way to look at it. So the vast majority of our metrics remain the same. We have the same amount of requests coming to the system. We have almost the same caching hit rate because only 1% of the traffic is being cache missed. And this is by purpose thanks to our CloudFront function. And we introduce only a very small amount of a new Lambda that is being served a new content to the bots. So the cost impact for it is going to be very, very minimal. And this is also can be adjusted. So if you want a less percent than 1, you can also do F% of the traffic is being cache busting. So this is highly customized for your own business needs. And as always, this is not enough. We wanted more. So we thought how we can get any new insight for our bots. So instead of just respond a new JSON, a new patch to our bots, we want to respond an images to the bots, right? And as we saw in the platform, the images, the images are being rendered with the browser. So we thought how cool it can be if the browser that's rendering the images will send us new metrics. And then we can correlate between the bots that's making the fetch request of the APIs and the bots that actually are rendering our images. So even here in our static routes, which usually is just being used for caching and proxy to S3, we introduce a new CloudFront function. And this CloudFront function is quite simple. all it's going to do is when bot is going to render an image, the CloudFront function are going to do an async console log and ship the metadata to CloudWatch logs. And then respond the same image so the bot doesn't even know that something happened behind the scenes for them. Yeah, let's see it in the demo. So, as before, if I want to associate a new function, I'm going back to my distribution, then to my behaviors. Now I'm going to check a different behavior, which is the static PNG's path. I'm going to add this new function and save it. Let's see the function code itself. It's going to be even simplified than the previous one. So let's see it here. So this is my handler. On the first 3 lines, I'm extracting the request metadata. And then it's simply console log of a JSON with all the information from the request that is important for me as a business to better understand and better analyze the traffic that is coming. So in this case, we want to make a correlation between the search request and the image request. So I log the same metadata, such as the user agent and the client IP, but also the JAF fingerprint that is being pre-calculated by CloudFront. So you're getting it out of free of charge within all the requests. I also console log the device type. So again, I can know if it's a desktop, mobile, iOS, Android, etc. And I also have the geolocation. And again, this can be highly customized by your own business needs. So I'm getting back to the platform. I'm doing requests as a normal human. Everything is working fine. And then I'm switching to bots. And still, those bots are being responded by their own images. But each time that this image is being rendered in the console, now we should have a log for it. Let's see if it's already fetched some logs. Yeah, so I will zoom in a bit. So you can see that instead of just having my API log, now I have the log for the bot's images. So I can see that it's a different client IPs that are actually rendering the data versus the kind of IPs that are fetching our APIs. Same goes to the user agents. Same goes to this and the Java fingerprints. So this makes us understand that there is a machine probably that's making the request and fetching the API for us. But this machine is trying to publish our content across the globe, and there is actual browsers out there that are rendering the image. So we can do, now we can even do our WAF rules even more complex than that. Because if we see a JAF fingerprint that is repeated as a render image or maybe as a API search, we can now block this specific JAF fingerprint or maybe create a new rate limit. So basically, we just expose many more metrics out there. Many more metrics and give your business the ability to control the traffic accordingly. We thought it would be best to simplify a bit the architecture. I saw many of you taking pictures of the architecture that we just showcased, and this is great. But we want to talk about the high-level concept, because every different product is built a bit differently. So I want to discuss how you can implement it with your own business. So we used WAF in our case in order to label the traffic, unlike the vast majority of the usage of WAF, which is blocking. And if you use WAF for labeling, now you have the upstream that can react to it. So we use CloudFront function to react to it, But if you have your own origins behind the scenes, your origin can be exposed to those labels as well. Within the CloudFront function, we use modified. So now the CloudFront function knew if it's a bot or not a bot and could react differently to those. After the modification, some of the traffic, 99% of the traffic, still got served by the cache, because this is what we wanted as a business. But the rest of the 1% got split into two different origins. And this is like more trivial architecture that you mostly see in the different patterns. But again, you don't need to replicate it step by step, just taking different concepts. So the takeaways that I want you to take back home and thinking about your architecture is split into three. First, and foremost, you need to be traffic aware. You should ask yourself, do you really know what goes on within your system? So in our case, we just used label for bot versus humans, but this can be for any business-related topic. So it can be different tenants tiers, like premium or freemium. This can be even sales, like if you want to route traffic from the EU to a EU region, you can do it using CloudFront. So rethink within your engineering team and your product team what kind of different metadata is related to your business. So we show cases about bots, but this literally can be anything else. Second, simplify. All the changes that Sneak and myself done during this live demo was done only using CloudFront and AWS WAF. We haven't introduced any change to our application. So you can think how much of your complexity you can move to the edge without actually impacting your engineering efforts. So rethink if there is maybe workload that you're currently doing in your own regions that you can simplify and decouple it to run on the edge. And last, create a synergy. Using AWS services is not just selecting one component and use just it. In our use cases, we used WAF, CloudFront Functions, and CloudFront Cache. So rethink about each one of those components, what value it brings to you, and now you can multiply this value by connecting all those components together. This reInvent session reInvent week is full of content delivery sessions. We have packed all of them for you, so you can take a screenshot of it. I know that some of those already passed, but most of them are being recorded. So this can be used later on when you want to pick some of those content. I will keep it here for a second. Yeah, everyone stop taking picture. Moreover, we curated those three articles for you. The first two is different articles that will deep dive into the concept that we discussed today about how the flow request is happening within CloudFront and WAF and the different approaches of using origin routing. And the last QR is actually about a pricing change that's we released 2 weeks ago. This is called the flat rate pricing plans, and it goes between $0 a month up to $1,000 a month, and this is a fixed price. So currently there is, and you get CloudFront and WAF out of the box. So this is give you like a very quick way to start using those different components that we just discussed with a very little price for it, and goes from there. And my ask for you, before you leave this room, is to do something good for the pets out there. So if you will open the AWS Events app and feedback this session, for every feedback, we are going to donate for a pet organization, nonprofit pet organization. So we really appreciate your honest feedback for this session. This will highly help us later on to shape this session. But it will also allow us to help other pets out there. So please use our AWS events to feedback this session. And thank you, folks. I was Itav.
Nick.
Have a happy reInvent week. Thank you.